Okay, folks. Where this example is to implement f, the function f, into just using two input lookup table. If you are to implement this using a three input lookup table, if it is given to you three input lookup table, right? This is actually a very simple problem. Okay, so all you have to do is this: if given to you is a three input lookup table, all that you have to do is this: 5, 6, 7. See, just put a minterm location and you're done. If you are to implement this using a decoder, we're going to need a 3 to 8 decoder. Okay, if you were given decoder, all that you have to do is this: just take the 4 minterm and add it, you're done. The complicated thing is that's what we're going to talk about, is just using only two input lookup table. Okay, so I went ahead and write out the f depending on which variable that we pick first, whether it's w2. So if it's w2, you look at this. If you pick w1, that's what's going to happen. If you put w0, this is what's going to happen. Okay, so the idea is we wanted to pick a variable. Let's say we call it x, and then the g, we let it be something. Okay, and and then the x, right? And it is a g0 on the other side. So that will make our implementation really simple. So what is going to get us to end up with, it will be something like this. Okay, so you would have the x right here, and whatever g the function is, however many variable, this is where the g things go, and that will be your f. Okay, so let's see what we can do. If you look at a, right? So if you look at a, we have, let's say we let, for a, if we let g equal to w1 and w0. Okay, the other side seems to be very complicated, so let's look at it. If we do a g0, okay, the De Morgan, this is using De Morgan. De Morgan's tell us that this is same thing as that. Is it equal to the other side? Okay, is it equal? Maybe this, right? Let's call this, maybe we can do some simplification on this. Is it possible? Let's look at it. So so look at, we can use this term and that term. If we use that two term, right? So we have w0, w1 w1, and we might be able to use this two term that will give us w1. It's actually equal to that. Okay, so for a, we can actually rewrite it. For a, we can actually rewrite f as w2 g w2 g0. Okay, so so we know that our structure is something like this. This is w2 right here, and we know that this is w0 and w1. Okay, so how do we figure out what is in this? Because this is g right here. To figure that out, because we were using w1 and w0, and when we have w1, w0, we can have four different cases based on input, and then we have g, which is equal to w1 and w0. Okay, and that we're calculating using this function is basically this. So we're just going to take that, put it in here, and then the last part of it, if you look at that function, right? This F, this the next table, based on this operation, and W2 not G ordered with W2 G naught, that in fact that is exclusive OR. For exclusive OR, it is actually this. Then you're done. So now the complication is, what if you didn't pick W2 to be the variable? Okay, you pick, what if you pick W1 or W0, as you can see in B and C? What do? So you could let G, you can let G be this. You could let G. So the question is this side, is it equal to G naught? Okay. For here, for C, you can let that be G as well. And the question is that equal to G naught? I can tell you for both cases, for B and C, it is not true. In fact, if you pick B and C, right, you're going to have this. Okay. Let's say if you pick B. Okay. So you have W2 and W0. So you have W0 and W2. W0 and W2. Okay. And then and W1. This will be what you have if you pick B, if you pick W1 as a beginning. So it gets really complicated. You actually need 5 to input LUT. If you pick correctly and wisely, you only have 2 to input LUT. Okay, for this right there, it's the same case for C as well, if you pick C. I hope this helps.